Alrighty, so here we are with the rational roots theorem notes. These are the 3-4 notes. So the first thing we're going to do is identify the fundamental theorem of algebra. Sounds like a good idea. The fundamental theorem of algebra is the degree of the polynomial is the number of possible zeros. So we've kind of alluded to it already, but for instance, let's say we look at this example. Notice that the degree is 3, and so that means that if we take a look at it, it's going to, at maximum, cross the axis at least 3 times. Okay? Sorry, at most 3 times. It could actually only pass through it once or twice, in fact, depending on kind of how it's set up. So for instance, it could go like that, or it could somehow just go up there and then down through only once. So it kind of just depends. Of course, being a degree 3, it would have to go through at some point. So either way, degree 3 means there are 3 possible zeros or x-intercepts. So, when it comes to the rational roots theorem, we are going to identify the possible roots or zeros or x-intercepts come from the quotient, yes, fraction, of the possible factors of the constant and the leading coefficient. So this is going to be broken down kind of in the next steps here from example 1. But the idea is that the rational roots, or kind of the possible rational roots, comes from this idea that you can take the constant, put it over the leading coefficient, and all of the factors of 6 matched with all the factors of 2 as fractions, positive numbers, negative numbers, all of those possibilities are going to be things that could potentially be those 3 roots. So, for instance, up until now, we've been looking at this and saying, okay, well, there's a tiny little 3, so out of all infinite numbers, there are 3 of them that work. So what this does is break it down into a smaller amount. Yes, of course, this smaller amount is going to be 12 options, okay, but 12 options is much more easily kind of weeded through than infinite, okay? So, in that case, we are going to find these options. It's not always 12, but it is for this one. So, alright, so first thing we're going to do, possible rational roots. I've already kind of talked about it, but remember that up on top here are the factors of the constant, and that in this case is 6. And then the bottom is factors of the leading coefficient, and in that case it's 2. So whenever I read things, it's usually left to right, and so I always end up messing up that this should be on top and this is on bottom, but it's not. It's going to be this back end first, and then the front. So then we have to make a fraction with all of the possible numbers that would ever multiply to be 6. Factors are multiples that would make 6. So the numbers that are going to make 6 are, well, a plus or a minus 1. And because I'm lazy, I'm just going to write plus 1 or minus 1, not like separate. Let's see, then the next one, 2 could go into that. And then 3. And then 6. So all of those are possibilities of numbers that could multiply to get 6. So again, shorthand of 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. So I didn't want to write all of those individually, so I wrote plus and minus out front. Okay. So then we have the number 2, and we want a plus and a minus of the fact that 1 can divide into 2, and then also 2. So According to the fundamental theorem of algebra, how many of these zeros could be solutions? And that is 3 of them. Again, fundamental theorem of algebra has to do with the power, or the degree. Alright, so what I'm going to do, let's see, I think I'll do it up here first, is I'm going to list every single possible zero. Now, again, I mentioned earlier there's about 12 of them. So, how do I do that? I'm going to start by taking the number positive 1 and putting it over each of these denominators. So, for instance, positive 1 over positive 1. Okay, but a 1 over a 1 is really just 1, right? Okay, so in that case, 1 is one of our options, one of our zeros. Alright, the next thing I'm going to do is put a negative 1. Let's see, I'll do 1 still. A 1 over a negative 1. So again, I'm going through this numerator with all of these denominators. So you can see how we might get a few of these. Alright, so 1 over negative 1 does in fact make negative 1, so that's another 0 I could try. Notice that it's set up as synthetic division, because that is the faster way of kind of seeing if something is a factor or not. Alright, the next one I'm going to try is 1 over positive 2. And so that gives me a 1/2, or 0.5. Maybe that'll be easier for you to kind of try out. Alright, and then let's see, 1 over negative 2. And of course that will give us a different result, so we do have to kind of have all that. Alright, so our next option is negative 0.5. Okay, moving on. The next one I'm going to try is the number 2, because I did try all of these over the denominator. So now I'm going to try 2. So the first one I'm going to do is 2 over positive 1. And 2 over positive 1 is 2, so there we go. Then I have the option of 2 over negative 1. And 2 over negative 1 is negative 2. So that's another one of our options of zeros. Continuing on in our list, we also have 2 over positive 2. But what does 2 over positive 2 make? 1. So we don't actually need to do 2 over 2 because that is already taken. Alright, then we also have 2 over negative 2, and that one is already taken as well. That's negative 1. So we don't need that one either. No repeats are necessary. Alright, you'll also notice that I skipped the number negative 1 in the numerator, and that's because it would have just given me these same results just in an opposite order. So negative 1 here, positive 1 here. So anyway, a little redundant there. Alright, the next option is going to be positive 3 over 1. And a 3 over 1 leaves us with a 3. And hopefully you're seeing our pattern, and so now you can see that 3 over negative 1 will also be one of our options, which means that we'll have a negative 3 as a 0. Alright, then I've run out of room up there, so we'll continue our chart over here. Let's see, negative 3 over 1 and negative 1 are still going to give us those results. And so now we'll do 3 over 2 and negative 2. So 3 over 2 is just 1.5, so that can work out. I haven't listed that one yet. And then we also have 3 over negative 2. And it's 3 over negative 2 makes negative 1.5. Alright, then our last ones are going to be 6 over 1. So our next option is 6 over a 1, and that's of course going to leave us with a 6. And then we also have a 6 over negative 1. Alright, and that is going to leave us with a negative 6. And then you'll notice that I'm skipping the last one because 6 over 2 makes 3, and we've already done 3, right? And 6 over negative 2 makes negative 3, and we've already done that. So you will end up seeing that quite a few of them will repeat, and so that's why that list is how it is. So those are literally all 12 of our options. Now again, that is a weird system, but basically you're just trying to do every single one of these numerators over every single one of these denominators. Yes, that does sound like a lot, but so does infinity. So again, trying to get our factors here. So how do I know if this is going to be a factor? Well, if the remainder is 0, then we have a factor. If it's not 0, then we don't have a factor. So, or a 0. So to start out, we will take the coefficients, which are 2, -9, 7, and 6, and we will try some synthetic division. So bring down our 2. 2 times 1 makes 2. -9 plus 2 makes 7. 1 times 7 makes 7. 7 plus 7 makes 14. 1 times 14 makes 14. 6 plus 14 makes 20. And since 20 is not 0, we are not going to use the number 1. Alright, moving on. Yes, it does take a while. Alright, so the first thing is we'll bring down the 2. -1 times 2 makes -1. Oh, sorry, -2. Hi. -9 plus -2 makes -11. -11 times 1 makes 11. 11 plus 7 makes 18. 18 times -1 makes -18. And 6 minus 18, or plus a -18, makes -12, which is not 0, so that's not going to be a factor. Alright, moving on. 0.5, super. So if we try 0.5, long division, or sorry, synthetic division, bring down our 2, multiply 0.5 times 2, we get a 1. Woohoo! Add the 1 with the -9, we get -8. Multiply -8 and 0.5 and you get -4. Add those together and you get 3. Excellent review of long division, synthetic division. 3 times 0.5 makes 1.5. And then sadly that also makes not 0. And you're saying, oh man, wouldn't it be nice if all those worked? Well, yeah, but remember that we're trying to find 3 of them, so here we go. Hint, this next one's going to work. Okay, so 2, -9, 7, and 6. Bring down our 2, multiply by -0.5, and we get -1. -1 plus -9 makes -10. -10 times -5 makes +5. 5 plus 7 makes 12. 12 times -0.5 makes -6. Add -6 and +6, and oh my gosh, we get a 0. And so that means that one of our, that means that one of our zeros, or real zeros here, is -0.5. Woohoo, we found one. Alright, so then we move on. Alright, next one is 2, -9, 7, and 6. Bring down our 2. 2 times 2 is 4. Add those together, we get -5. -5 times 2 is -10. Add that together and we get -3. -3 times 2 is -6, and holy heaven, we get 0. So that means one of our other zeros is 2. Super, continuing on. Alright, we get 2, -9, 7, and 6. Bring down the 2, and we get a -4 when multiplying. Add those together, we get -13. -13 times -2 is positive 26. Add those together, and we get 33. 33 times negative 2 is not going to make you 0. But it's negative 66. Add it together, and we get negative 60. Which is, again, not 0, so darn it. Alright, moving on to the number 3. Is this tedious? Yes, but so is infinity. So, more so. Bring down a 2. 2 times 3 is 6. Negative 9 plus 6 is negative 3. Negative 3 times 3 is negative 9. Negative 9 plus 7 is negative 2. Negative 2 times negative 3 is negative 6. And oh my gosh, it's a 0. When you add it together. So, we have now found our 3 zeros. So we don't have to continue with any of these because we've already found all 3 of them, so we know they're not going to work. If you want to do extra work, go ahead and practice your synthetic division with those. But by the luck of the draw, we got all 3 of them, and so we can stop. So, we're going to use these zeros to write the polynomial in factored form, which means that if these are all the zeros, the factors are the opposites. So, for instance, opposite of negative 0.5 is plus 0.5. Opposite of positive 2 is negative 2. And opposite of positive 3 is negative 3. So, that is the polynomial in factored form, because we didn't have to kind of expand it or anything new, thanks. And we got it by doing our possible rational roots. So, in review, the fundamental theorem of algebra says, what's the degree of the polynomial? That's how many zeros there are. Rational roots theorem says that if you go ahead and make this fancy fraction of the constant number, the last number, and then the first number, the leading coefficient, all of its possibilities broken down, okay, you are going to get the fact that 3 of them will work. So then we do synthetic division with all of the zeros that are there. Mark down our zeros, not changing anything, it's always that same number, but then flipping the sign when we get to zeros, or the factors. So change the zeros into factors to make a polynomial. So your assignment is going to be doing this twice more, and you'll see that there's not necessarily a lot of room for all of the work for those. So you can, of course, go onto a different sheet of paper. So, excellent, good luck. Can't wait to see what you come up with.